Hello, I'm Stefan Graeber, I'm the project leader for LXD, and continuing with our recent theme of LXD network features, this time around I'm going to be looking at LXD network forwards. LXD network forwards are the name that we use for what others might refer as floating IPs or elastic IPs or elastic addresses. Effectively, it's a way to have a external or public IP that is forwarded to a internal address. But LXD's implementation does slightly more than that. It's not just a one-to-one mapping between an external and internal address. It also lets you do that kind of forwarding, but on a per port basis. So you can decide that one or multiple ports on a given external address will go to a specific instance, some other ports to another instance, and then whatever is left goes to, say, a third instance. So that makes it a bit more flexible. And it's supported in LXD with both normal bridged networks as well as oven networks. The documentation I've got open here kind of goes through the concepts and what's possible to do. So as mentioned, there is effectively an address that's being listened on, description, configuration to set what the default target is, if any, and then the ability to do on a per port basis overriding things. There's some slight differences for like what addresses can be used as far as the listen address, whether using bridge or oven networks. It's documented there. And then more details on how to actually do the per port configuration. So let's look at how that works in practice. So here I'm just looking at my normal desktop machine. If we look at the networks, it's reasonably standard. The only difference is I've got a demo network here, but we're not going to touch that today. Instead, I'm just going to be using the LXD BR0 network, which is here. Now, if we go look at, let's see, network forward, you can see that currently there are none defined. Now, there are two things we can do with forwards. One is we use an address within the network range itself. So in this case, the 172.17.250 subnet. Or we can use an external address. So first, I'm going to be starting with an internal address. So I'm going to be forward create on LXDBR0 and let's say 250.10. Okay, so that's created. Now, if we go look and try to ping this, it should not respond because currently it is not forwarding to anything. The first thing we're going to do is make it forward to some instance. So let's pick the IP address of an existing instance. In this case, that's speed test instance here. And then do next network forward edit of that particular entry. Here we go. We can also give it a description. So we can do my first forward. And then in the config, put a target address of that specific container. Save. Try to ping again. Now it hits the container directly. So that all works. Now down here, let's also get a shell inside of the container. And then use netcat to bind port 1234. And then try to connect to it using the forward, so 172.17.250.10 on port 1234. This makes it through. Okay, so that's kind of the basics. At this point, you've got an external address. Well, in this case, an address from the same network is forwarding to another address. But let's make things slightly more interesting. So what we're going to be doing instead is defining a port. I can give it a description. Let's go to netcat. The distant port that we care about here is 1234. And then the target address is what we had before. And no need to change the target port. That would just be if we wanted to also alter the port. So doing this, forward to enter the protocol. Sorry about that. Protocol TCP. Okay. So with that saved, now we should see the exact same behavior. So I can start netcat, I can connect to it, it works. But if I ping the address, it's not pinging because there's no default address anymore and ICMP is not handled, so it doesn't ping. Now, let's tweak things a tiny bit further. So I'm gonna pick the address of another instance, in this case LXD build, and we're gonna be putting that as the default address here. Okay. And then let's also change the target port here, so that target port is 1234, but listen port is 80. Save that. And just looking back at that config, what this means is if it's port 80 TCP, it goes to 1234 on the specific instance. We can test that. That works. Which means if I try 1234, it should not work. And it doesn't. And anything other than that port 80 actually goes to that other instance. So if we go to that LXD build instance instead, and we bind 1234 and we connect here on 1234, that's now going to this one. Because if you want to go to the other one, you need to hit 80, at which point it hits the other one. So that works as designed. And that's pretty much the basics. I mean, you can definitely expand on that and then add more and more ports on UDP, on TCP. As mentioned, you can do ranges of ports as well, which should actually work. So in this case, I could probably do 80 and 1235. Oops. Both of which would go to 1234. Let's see. So if I start my netcat here and I try 80, that works. Reset, try 1235, same thing. So you can do comma separated ports. You could also do an actual list of ports. So say we wanted 80 through 90 to head to 1234. Change that. Restart the listener over here. And try, I don't know, 84. And it goes there. And just to make sure, try 79. No answer. If we try 91, no answer. So that's pretty much what this offers. It's pretty flexible, really lets you save on IP addresses by actually having just like 1 or 2 public IP addresses and then kind of fanning out the traffic based on ports to a variety of instances. But the other thing that I can show is just how to do this now with a public address, or at least an external address. Because just as a reminder, what we have right now is we're using that 172.17.250.10 address, which is part of the IPv4 subnet of the LXDBR0 bridge, which means it works here because I'm on the host and it will work from within instances on that network, but it's not going to work from, say, my laptop. Now, if I wanted to work from my laptop, there's kind of 2 things I can do. One thing I can do is look at the IP addresses on my system, find the IPv4 address that I've got externally, and then use that as a forward. The downside to this approach is LXD is going to effectively be in charge of the entire address, which can conflict with potentially other services you've got on the system. What you can do instead is maybe add another static address to your system. So in this case, I'm going to be doing, so it's on ENP3580. I'm going to be adding another address, 172.17.0.100. So now I've got that address on my system itself. This is pinging because the address is actually on my system, and anything that's not handled by LXD will just land on my system at this point. Now, we can go through LXD network forward create. It's still gonna be part of LXDBR0 because it's effectively the network that we want to forward to. And then the IP address is 172.17.0.100. So I'm putting that in place. And I'm not gonna be doing a super complicated example for this one. I'm gonna just be forwarding everything to a single instance to just show that it works. So again, I'm going to use that speed test instance, which is that IP address, work forward edit LXDBR0 100, and go to config, target address, the speed test, and it's already listening currently on port 1234 down here. And I'm just gonna switch over to my laptop over here. And now do 1, 2, 17, 0, 1, 100 on 1, 2, 3, 4. And we can see it made it here just fine. So if we do another message, there. And that's pretty much it for network forwards. As I mentioned, they work pretty much identically, whether you're using them with Bridge or with Oven, which is why I'm not gonna do the demo again on Oven, because there's really not much point. You effectively have a list of addresses that LXD can manage, and you can then choose whether you want some specific port or the entire address to be forwarded to any instance that's on that particular network. And you can change all of that live to the LXD API, and it just works. It's really nice and flexible, lets you save a whole bunch of IPs compared to other approaches, and can also be more flexible in some ways than, say, using a proxy device or a dedicated address that you're routing straight to an instance. And I hope this was useful to you. That's something that you might be able to use in your own deployment, your own projects. If you've got any questions, you can leave them down below in the video, or you can go on our community forum. We'll be more than happy to help you. And I'll see you in the next video. Thanks. Bye.